Hi everyone, today I am going to tackle about Pitrinets specifying asynchronous system. So, Pitrinets. So what is Pitrinets? Pitrinets are a formalism for specifying systems that contain parallel or concurrent activities. So we have here the quadrupole. We have called the PTFWM, which is P represents as the places, T transitions, F flow, weight, W weight functions, and M is the initial marking, where P is the infinite places, the T infinite transition, and the F is the flow of relation, while Pm without the initial marking is denoted by N, that is consist of P, T, A, W or places, transitions, arc, and weight function. While Pn, it consists of, with initial marking, it consists of the N and MO. So, Pitrinet, it consists of two nodes. The first one is the places, and the second one is the transitions. So I am going to discuss about transition and places and identify that one. So it also consists of arc, which exists only from a place to a transition or from a transition to a trace. So graphical representation, we have here the places. This is the symbol of places indicated as the circle. The transitions, it is indicated as the rectangles. Arcs, it is indicated as the flow element of arrow, this one. So note that Pitrinet is given a state by making it places. Another example also, that it's stated here that Pitrinet is primarily used for studying the dynamic concurrent behavior of network-based system where there is a discrete flow. So for transition it have one or more input or output places. So it can be fireable or embedded when there are sufficient tokens on its input place. So in transition, we have two types. The first one is the input place, and the second one is the output place. So input place, it is indicated as old state, and it is an arrow goes from a place to a transition. So this one. And for the output place, also called as the new state, if an arrow goes from a transition to a place, indicated as this one. So enabled a transition with no input places. So let's take a look for the first example. From this one, the places is going to be fired into the other places because the transition node is ready, and then there is at least one token and at each of its input devices. So this one, this symbol, the color block is indicated as the token. Next, so this is the example of the Pitrinets. We also have here the properties of Pitrinets: the sequential execution, the synchronization, the merging, concurrency, and conflict. So for the sequential execution, the transition can fire only after the firing of T1, like this. So you cannot fire T2 to places P3 if you are not done firing the T1. Okay, again, we can fire if you only have one token here, like that. For the synchronization, the transition will be enabled only when a token there, or at least one token and each of its input places. So if we have one token from this place into this place. That's the synchronization, how synchronization works. For the merging also, it happens when token from several places arrive for service at the same time, or transition. So if these places here contains no tokens or two tokens, so it would merge after the transitions that is to be fired. So the output would be like this. And for the conflict concurrency, the transition 1 and transition 2 are concurrent with a property. So the Petri-net here is able to modelize the system of distributed control with multiple processes. Lastly, for the properties of Petri-nets, we have the conflict. So the transition 1 and transition 2 are both ready to fire this one. But the firing of any leads to the disabling of the other transition. Why? It is because the resulting conflict may be resolved in a purely non-deterministic way or in a probabilistic way by assigning appropriate probabilities to the conflicting transition. And for lastly, we have here the two types of scenario in a restaurant. We have waiter and two customer. So in this scenario, in scenario 1, the waiter takes an order from customer 1, tell it to the kitchen. The kitchen would going to prepare it, and after that, the customer would wait. After the waiter would going to serve the food, and after serving the food to customer 1, the waiter would going to take the order from customer 2, and then the customer 2 would wait because the waiter would going to tell it to the kitchen. Then after telling to the kitchen, the waiter, when the food is cooked, the waiter would going to serve the food to the customer 2. And for the scenario 2 also, in a restaurant, the waiter would also take the order of customer 1 and take the order of customer 2. Then after that, tell it to the kitchen. When the process or the food is finished, the waiter would going to serve first the order to the customer 2 and to the customer 1. So that's how Petri-net works. That's all for today. Thank you.